Hello everyone, welcome to Sources classes. So in this video again we have come up with a very interesting question pertaining to the quantitative section, and the question that we will be dealing with is of HCF and LCM and basically number of pairs of possibilities. Okay, so this sort of question pertaining to HCF and LCM are quite common in this sort of examination, be it your GMAT, GRE, the QA section in general. So in one way, one form or the other, we often see or come across this sort of question. So it's really essential that we get a general idea with regards to the approach of the same as well. Okay, having said that, what we'll be doing in this video, we'll take a look at the particular question from the particular section as well. We'll try and solve the same and also get a general idea about how to go ahead and solve this question. Okay, so without that said and done, let us just focus on the question at hand. How many number of pairs can we produce such that HCF is equal to 8 and LCM is equal to 502656? Okay, so it's given that HCF is 8, LCM is 502656. Okay, now let's try and understand one thing. Suppose I have a number AX, another number BX, so HCF can be written as X. Okay, so, and LCM can be actually written as ABX. Okay, where X is the common HCF in this regard, then A and B are the subsequent numbers. Now we can use the similar concept in this question as well. So we have 8 as the LCM and let this be the co-primes A and B. Okay, let A and B be the co-primes and this will be equal to LCM 502656. Simply we use this concept. Okay, now if I try to cancel this by 8, 48, 22, 66, 8, 64, 3 and 2. Okay, so A into B can be written as 6, 2, 8, 3, 2. Okay, so this is what we have. Now let us try and split 6 to 8, 3, 2 into the prime factors. So this can be written as 6 to 8, 3, 2. Okay, this is 2, 7. Okay, 9 and 11, 12. So this is 21. So it goes by 3. 3 1 0 3 3 0 9. So next up 7 if I go. 7 1 7 87. 11 0 17. Yep. So wow, so this is the split, that is 2 to the power 4 into 3 into 7 into 11 into 17. Okay, so basically we have 5 prime factors. Okay. So therefore number of ways we can form a pair will be 2 to the power n minus 1, where n is number of prime factors. Okay, so 2 to the power 5 minus 1, that is 16 will be our answer. Okay, so I hope this question is clear to you, how we came about with the solution of the same. So this is a sorry, my bad, this is a very important concept with regards to how we came about with the solution. So I hope you got a good idea in this regard. So please make sure you make a note of this particular concept. Okay, oh sorry, not this thing, this formula. So if you're looking for a detailed solution of the entire paper pertaining to all the section, please feel free to connect with us and we'll be more than happy to help you out. Now, having said that, if you like the video, make sure you like, share and subscribe to the channel so that we can keep coming up with relevant content such as this further down the line. So with all that said, I'd like to sign out. So thank you so much.